So we are on a section actually mint your NFT locally, mint NFTs. Now that we have all the data nicely set up for our character, the next thing to do is actually mint the NFT. Let's go through that process. Here's my updated contract, and I put a comment above lines change edit to make it easy. Okay, let's just copy this smart contract and paste it here. Let's see, a lot of stuff going on here. First thing I do is create two state variables, which are sort of like a permanent global variables on the contract. uh, you can read about more about them here. What are state variable and what are local variables? So these are, here it is. So here we have created these two state variables. NFT holder attributes will be where we store the state of the player's NFTs. We map the NFT's ID to a character attributes structure. Remember, every player has their own character NFT, and every single NFT has their own state like HP, attack, damage, etc. Okay, okay. So if player 172 owns a Pikachu NFT and their Pikachu NFT loses health in a battle, then only player 172 Pikachu NFT should be changed. Everyone else Pikachu should stay the same. So we store this player character level data in a map. Right. Next, I have NFT holders, which basically let me easily map the address of user to the ID of the NFT they own. In mapping address, this one is the index and this one is the value, and this is the variable name where we are using. For example, I would able to NFT holder insert public address here and instantly know that NFT that address owns is just helpful to keep this data on the contract so it easily accessible. Okay. Now what is ERC21? You'll also see the inherit of a Zeppelin contract using ERC21. Here it is. Here it is. And declare a contract, you can read more about inheritance here, but basically it means we can call other contract from ours. Is almost like importing function for us to use. The NFT standard is known as ERC21, which you can read bit about here. OpenZeppelin essentially implements the NFT standard for us and then let us write our own logic on top of it to customize it. That means we don't need to write a boilerplate code. It'd be crazy to write HTTP server from scratch without using a library, right? Of course, use less unless you wanted to explore. Similarly, it'd be crazy to just write an NFT contract from complete scratch. You can explore ERC21 contract we are inheriting here. So Open Zeppelin, when we import the Open Zeppelin or we inherit Open Zeppelin, so we have access to all the function that it's providing. So it's a great way to start, or it's an easy way to start getting a smart contract by just importing files rather than just creating each function, because we don't have to reinvent the wheel because they have provided all the required function related to ERC21 and other standards, and also provide many security functions and many security libraries. So we will going to use them in our code, so we don't have to rewrite these logics. Rather just call that function from our base contract, which is provided by OpenZeppelin. So let's move on. Token ID increment. Okay, so where it is, here it is. Yeah, the main character and object function, and here it is. Okay, so we're gonna start at 0. It's just a counter increment, just add 1. You can see it here in the OpenZeppelin code. Here it is. In the constructor, increment it to 1. Why? Basically, I don't like dealing 0 in my code. In Solidity, 0 is default value, and I try to stay away from default value. Just trust me on it for now. Okay, so here it is. The constructor, the default value of token ID is set to 1 because it incremented value 1. So now our token will be start from 1. Min character NFT function is where the actual minting has been happening. First, you'll see that we pass in character index. Why? Well, because players need to be able to tell us which character they want. For example, if I do min character NFT 0, and the character the stats of default character 0 is minted. Okay, from there we have a number called new item ID. This is the ID of the NFT itself. Remember, each NFT is unique, and the way we do this is we give in each token a unique ID. It's just a basic counter. Token current start at 0, but we detect token increment is constructed, so it will start at 1. We are using token ID to keep the track to the NFT unique identifier is just a number. So when we first call main character NFT, item 1, when we run it again, item 2 will be 2, and so on. Token identity state variable, which means if we change it, the value is stored in the contract directly, like a global variable that is stay permanently in memory. So here it is, as we have already seen that it's getting the new token ID every time, because here we incremented the token ID. So now let's move on to the next line, which is safe underscore mint. In the center, new item ID. There's a magic line when we do safe minting as a center, comma, new item ID. It's pretty much saying mint the NFT with the ID, new item ID, to the user with the address. As the sender is a variable. Solidity itself provides that easily gives you access to the public address of the person calling a contract. Message the sender will have a wallet address of the user which is calling this function. If I am calling this function, then my wallet address will be here. So we know that which user is calling this function. You can't call a contract anonymously. You need to have our wallet credential connected. This is almost like signing in and being authenticated. What awesome here is that is a super secure way to get the user's public address. Keeping the public address itself a secret isn't an issue. It's already a public, everyone sees it, but by using message sender, you can't fake someone else's public address unless you had their wallet credentials and call the contract on their behalf. Holding dynamic data on an NFT So as player play the game, certain values on their character will change, right? For example, if I have many my character attack the boss will hit back. In that case, my NFT HP would need to go down. We need a way to store this data per player. Here it is. A lot of basically our NFT holds the data related to our player's NFT, but this data is dynamic. For example, let's say I create an NFT by default. All my NFT starts with the default sets like character, text one, name, image or HP, XP, attack damage. Remember, every player has their own character NFT. NFT itself put data on the state of the character. So here it is. We are adding it in NFT holder attributes, and this is basically a array, struct array that we are using, and adding the values. Sorry, because it is the struct, not an array. Struct, we are adding the values in it. Here it is, default character values. Let's say my character is attacked and loses 50 HP. Well, then HP would be from 200 to 150, right? That value would need to change on the NFT. Here it is. Or we want our game to have upgradable characters where you can give your character a sword and add plus 10 attack damage from 50 to 60. Then attack damage would need to change on the NFT. People often think that NFT metadata isn't allowed to change, but that's not true. It's actually up to the creator. In this case, our character name and character image never change, but its HP value will definitely does. Our NFTs must be able to maintain the state of our specific player's character. This is why we need the variable NFT holder attributes which map the token ID of the NFT to a struct character attributes. It allows us to easily update value related to the player's NFT. It means as players play our game and their NFTs, HP value change because the boss has them, we actually change their HP value on NFT attributes, and that's how we can store player specific NFT data on our contract. Next we do is NFT holder manager send new item ID. Map the user's public wallet address, NFT token ID. What this lets me do later is easily keep track of who's owns which NFT. So this will keep track of which user as the sender have the new item ID. So it will keep track the which user have which NFT. Right now, there's a design where each player can only hold one character NFT per wallet address. If you wanted, you could adjust this to where players can hold multiple characters, but I stuck with one character per player for the sake of ease. This is our game to whatever the heck you want. Okay. Now this is the increment file after the NFT is minted. Increment token ID using token increment, which is a function. Open them gives us this. Make sure the next time an NFT is maintained, it have different token identifier. No one can have a underscore token IDs that's already been minted. So let's run it locally.